Having just learned about levers, we are going to now test it as a simple machine. So remember, all the simple machines we've learned about has in some way made some kind of job easier for people. So with the lever, we're going to be testing, does it make lifting an object any easier? Does it make us use less force? So does the placement of the fulcrum affect how many 10-cent coins it would take to lift two 50-cent coins? Now, let's take a look at what I mean. So what we're going to be doing is we're going to be doing an experiment where we make a simple lever using a ruler and an eraser, as you have seen before. And then on one side, the load will be the two 50-cent coins. And on the other side, our force will be the 10-cent coins weighing down the other side. What we will change is where the arm is placed on the fulcrum, meaning the load will either be close to the fulcrum, a fair distance, or farther away. So as I show the markings on the ruler, at 12 centimeters, the load will be close to the fulcrum. At 15 centimeters, it will be in the center, meaning that the lever will be equal on both sides. And at 18 centimeters, the load or the 50-cent coins will be far away from the fulcrum. What I want you to do is look at your hypothesis and think, where will we need to use the least amount of 10-cent coin? When will we need the least amount of force to raise the load? Will it be when the fulcrum or the eraser is close to the load, at the center, or at the far end? Okay, so please choose one and pause the video to record your hypothesis. So which one do you think and why? Now, this is still an experiment, so we still have independent variables and constant variables. So remember, the independent variable is what are we changing in this experiment, and the constant one is what we're keeping the same. So the thing that we are changing is the position of the fulcrum. Position of the fulcrum or the eraser on the lever. Okay. The things that we are going to keep the same, we are obviously going to keep the same materials, so we're using the same lever materials. The weight of the coins is the same. So the 50 and 10 cent. So I'm not sticking in a $2 randomly. Okay. And then the other thing is we're testing the lever all on the same surface. So the desk at school. So I'm not testing it over sand and something else. What we are going to do is first we're going to make a simple class 1 lever, meaning the seesaw as you saw, and then we're going to test it first over the center at 15 centimeters. Then we'll test it at close by at 12 centimeters, and lastly at 18 centimeters. And again, your hypothesis should have been guessing which one would take the least amount of 10-cent coins to tip the two 50-cent coins. As we do this, you will have to make drawings and insert them as your observations. Now, first we'll put the middle of the lever over the eraser and put our load, which were the two 50-cent coins, on one side of the lever. And on the other side, we'll use our 10-cent coins as our force to lift up the load. So 1, 2, 3, 4, 5, 6, 7. So it takes 7 coins to lift the load at the center of the lever. So let's record the number of 10-cent coins needed to tip the lever. So this one needed 7 coins. Here's the drawing for the lever placed 15 centimeters. So I'll draw the fulcrum first, which was, of course, the eraser. Don't forget your labels, please. Next is the arm of the lever. Try to make both sides equal because, again, it should be right in the middle. next two 50-cent coins for the load. And then on the other side, we will do the 7 coins. That was the force. Okay, and the force is going in a downward motion. Sorry about the subtitle, I accidentally wrote the wrong thing, but that should be labeled as force. So you can pause the video so you can draw it and take a photo. Okay, so when we're done, we'll insert our photo here from the computer. So here's our 15 centimeters. I'm going to make it a bit smaller, it's kind of large. Okay, here's the second test where we'll shift to the close side, the 12 centimeters. So as you can see, when we put down the 2 coins, they're a lot closer to the fulcrum. And now the 10-cent coins. So 1, sorry, tipped a lot, and 2. It doesn't need the third one. Looks like 2 is enough to tip it. So here's the drawing of the 12 centimeters. So again, starting with the eraser or the fulcrum and making sure to label everything. Now remember, when we draw the arm of the lever, the side on the left should be shorter than the side on the right. So I'll just make it shorter there. And then draw the 2 coins for the load, and then the 2 coins that were the force. And again, this force was pushing down. So you can pause the video so you can draw and take a photo of it. So let's insert our photo and record our observations. And then remember that this, it only took 2 coins. For our last test, we're going to shift the ruler to 18 centimeters, meaning that the load will be further away from the fulcrum. Okay, so our 2 coins are on the left side, and now we will do the 10-cent coins. So 1, 2, 3. Let's just fast forward through this. And at the very end, we have 14 coins. Now the drawing for 18 centimeters. So starting with our fulcrum, the eraser. This time, the side for the load should be longer. And I'll draw the 2 coins for the load. And then again, on the other side where the force is, we're going to be drawing 14 coins for the force. And again, the coins are going in a downward direction as the force. So let's record our observations and insert our diagram. And it took 14 coins. Looking at our test results, when the fulcrum was in the middle, it took 7 coins to tip the load. When the fulcrum was closer to the load, it only took 2 coins. And lastly, when the fulcrum was far away from the load, it took 14 coins. So what we learned is that the best position for the fulcrum to tip with the least amount of weight, or 10-cent coins, is when the fulcrum is close to the load. So now you need to think about, why is this happening? Why does this, when it's close to the load, why does it make it easier? And you might get a hint by seeing how long the other side of the lever is. And it's because the other side of the lever actually gives more weight and therefore more force to help balance it. So because most of the ruler was on the other side, that weight was used to lift the load. So this is because there there is more weight on the other side of the lever, making more force to lift. And we talked about this with pulleys, but this gives it a greater mechanical advantage because we're using less force or less coins. By using less coins, we have a greater mechanical advantage. So again, if you want a lever to make your job easier, you want the load to be close to the fulcrum. And this can be any kind of lever, class 1, class 2, or class 3. As long as the load is close to the fulcrum, you'll use less force. So as a review, we're just going to go over some definitions. So remember, force is the push or pull that makes an action. So you apply some kind of force and then something will happen. The fulcrum is the pivot point a lever moves around. So in this case, the ruler moved around the eraser. In the case of a door, it moves around the hinges and so on. And the load is the weight or resistance that is being overcome. So the load is some kind of weight or thing that you need to overcome, meaning maybe you need to lift it up, you need to push it somewhere, it needs to be moved somewhere. Now with levers, an important part is balance. So it's a state of equilibrium. So we hear that word in math, equal. So what it means is where both sides have equal forces. And lastly, mechanical advantage is measuring the amount of force used to lift or move a load. So when you have less force, that equals a greater mechanical advantage, and more force equals less mechanical advantage. So please copy these definitions down and try to understand them as they will appear on our unit test. Okay? If you have any questions, please send me an email or contact me on Google Hangouts. Bye!